Good afternoon. Myself Swapnil Bhosle. I am studying Master of Computer Application in Vishweshwaraya Technological University. I am doing project on crop yield prediction using machine learning. Chapter 1 Introduction. The problem statement of this project is due to the major difficulties facing the agriculture business which will result in higher costs on an economic and environmental level. Farmers feel increased pressure to adopt intensive farming technique and suitable agriculture practices. We proposed a machine learning, auto demand and yield prediction approach to address this problem. Farmers how manually predict the demand for grains and vegetables, which has an economic impact on farmers. The proposed solution is farmers are under greater pressure to embrace intensive farming methods and sustainable agriculture practices because of the significant challenges facing the agriculture industry. This will result in higher cost on an economic and environmental level. To solve this issue, we suggested a machine learning auto demand and yield prediction approach. Farmers now manually forecast grain and vegetable demand, which affect the economy. Purpose of this project is crop yield forecasting is used to help farmers, agricultural companies and government make educated decisions about crop management and output. Example of this include deciding which crop to cultivate, when should you plant them and how far care them to increase productivity. Crop yield prediction could help farmers maximize their farming practice and utilize the most of their available resources and land. Farmers may use yield prediction to decide which crop are most likely to be productive in a specific year and to adjust their planting and management strategy accordingly. Waste might be reduced and crop production efficiency could be increased as a result. Crop yield prediction can be employed by government, agriculture companies and farmers to prepare for future food and ensure that there is an adequate food supply to meet demand. This might help both developed and developing countries experience greater food sustainability and security. Overall, crop yield forecasting is a critical tool for boosting agriculture production efficiency and guaranteeing that there is enough food to meet demand of the world's growing population. Scope and limitations. Crop yield forecasting aim is to help farmers, agriculture companies, government make educated decisions about crop management and output. Example of this include deciding which crop is to plant, when to grow, how to care them to increase productivity. Crop yield prediction is help farmers optimize their agriculture practice and make all the land resource they have to do their disposal. Farmers can yield production to identify that crops that will likely produce in a specific year, for example, and to adjust their planning and management strategy accordingly. Waste may be reduced as a result and crop production efficiency may be increased. Crop yield forecasting is useful for both farmers and agriculture business and government who can use it to prepare future food needs and ensure that there is adequate food supply to meet demand. This might help both developed and developing countries experience. Overall, crop yield forecasting is essential tool for boosting agriculture production's efficiency and guaranteeing that there is enough food the demanding of world growth population. Chapter 2 Literature Review. The domain survey of this project. Machine learning. Machine learning is a subfield of computer science and artificial intelligence. Uses data and algorithm to replicate human learning processes and steadily increase accuracy. Machine learning algorithms have the capacity to improve, as well already mentioned. There is no room for error in algorithm-based computer operations that follow established steps. Sometimes, rather than writing orders to carry out an action based on input, computers make decisions using example data that is already available. Like individuals, computers can, when making decisions in some circumstances. Supervised learning. Machines are taught to anticipate the outcome using supervised learning techniques after being educated using precisely labeled training data. Information that has presently having associated with the desired outcome is referred to as labeled data. Unsupervised learning. Machine learning technique known as unsupervised learning use training datasets without any active model supervision. Instead, models explore the existing data to find previously unnoticed patterns and insights. It is comparable to the learning that occurs in the human brain while acquiring new information. Reinforcement learning. Reinforcement learning is one of the specialized area of machine learning. It comprises adopting actions that will increase that profit in a particular situation. Numerous computer programs and applications use it to choose what action to take in a particular circumstances. In contrast to supervised learning, reinforcement learning relies on the reinforcement agent to determine how to accomplish the job at hand. An answer key is provided by the training data in supervised learning. Since the solution is already known, the model is trained using in supervised learning. In the absence of training dataset, it needs to make mistakes to be able to learn. Existing system. A variety of existing techniques for predicting agriculture production utilizing machine learning algorithm and statistical models can forecast how many crops will be produced in a given year. These techniques can be used by farmers, agriculture companies, government to make educated decisions on crop management. The crop forecasting of the USDA is one of the example of a crop yield prediction system. It uses combination of meteorological data and machine learning algorithm to forecast crop yields for important American crops. The CYFS offers projection for number of crops including maize, soybeans, wheat, cotton. It is consistently updated. The Agricultural Model Intercomparison and Improvement Project, a global research initiative, is another example of a crop yield prediction system. AGMIP forecasts agricultural yield for a range of crops around the world using weather data and machine learning technique. AGMIP consists of a number of regional and global crop production models to better understand how numerous factors such as weather, soil condition, and management approaches affect crop yields. Other small-scale agricultural outcome prediction systems that are customized for certain locations or crops exist additionally to these large-scale ones. These systems could make predictions about agricultural yields for particular regions or for certain crops using a variety of data sources and machine learning approaches. In general, there are a number of crop yield predictions systems in use today that are statistical model, machine learning algorithm to support farmers, agriculture, business, and government in making well-informed decisions. These programs could help increase agricultural productivity and efficiency. Comparative study of existing system. Several machine learning based approaches to estimate agricultural yield are available as well already mentioned. The proposed system most notable and noteworthy accomplishment is that it outperforms the current system. In terms of accuracy, when compared to both the current system and suggestion system, due to differences in the algorithm and datasets used in the two systems, the proposed method offers 99% accuracy that our previous system has never offered. Tools and technologies are used in this project. Tools. System processor is i3 4th generation or above. Hard disk up to 500 GB and RAM is 4 GB and above. Technologies are used. Operating system Windows 8 or 10 64-bit operating system. In this programming language is Python 3.9.12 version. Framework used is Anaconda 4.12.0. Libraries are used as Keras, TensorFlow. IDE is Jupyter Notebook and frontend for Flask 1.1.2. Feasibility study. First one is technical feasibility. Theoretically, one could estimate agricultural using machine learning to predict agricultural yield in future. Machine learning algorithm and statistical models may be trained on historical data utilizing inputs like state name, season name, crop name, area size, and rainfall conditions. Crop productivity can be predicted using variety of machine learning methods, including unsupervised learning method like clustering, dimensionality reduction, as well as supervised learning. Methods like decision trees, random forest, and neural network. These algorithms might be able to predict future agricultural production using inputs like state, season, crop, size, rainfall, etc. Upon analysis of the data, the prediction of agricultural production using machine learning quite technically feasible given that a variety of approaches and procedures may be employed. A produce reliable forecast based on a variety of data sources. It is crucial to understand that there will always be some degree of uncertainty and that these productions are not flawless. Second one is economic feasibility. For farmers and the agriculture sectors, using machine learning to predict crop yield may offer a number of benefits. Farmers can increase productivity and profitability by making planting and harvesting decisions based on precise yield projections. The price of building a machine learning model for predicting crop yields will depend on a number of variables, including the number of amount data available, the resource needed for a data collection and pre-processing, the complexity of the model, and the cost of necessary hardware and software. A free open source application called Jupyter Notebook was used to create this model. Kaggle gave the data for free. Neither outside source nor pre-processing were employed. Next one is operational feasibility. Operational feasibility is the practically and simplicity of putting a proposal into action. You should take into the account the following elements while evaluating the operational feasibility of a crop yield forecast system utilizing machine learning. Next one, data availability. The model needs data to be developed, hence the dataset was collected from Kaggle. The dataset contains about 70,000 records and it is useful for both training and testing the model. The model can be trained and tested with just the data. Software and hardware requirement. Both software and hardware are required to build this model. The Anaconda Navigator, software and hardware specifications required to build this model include a PC with i3 4th generation or above, hard drive with at least 500 GB space, and RAM with 8 GB and higher. The next chapter is hardware and software requirement. First one is hardware specification. Specification and design. Processor is Intel i3 7th generation, memory 8 GB, hard disk 500 GB. Software specification is operating system Windows 10, software Anaconda Navigator, IDE is Jupyter, and framework is Flask. Next one is software requirement specification. Users. First one is farmers. Using predictive models, farmers may ability to get the most out of the inputs and decide when to plant, harvest their crops with more knowledge. This could result in higher cost and yield. Agribusiness. Agriculture businesses that produce or sell agriculture inputs such as seeds, fertilizer may better understand market demand and optimize their production and distribution by using yield prediction models. Third one is government and policymakers. Accurate yield forecasting can have an impact on decisions about food security and agricultural policy. Researchers and academics. Yield prediction is a vital area of study for academics and researchers that are interested in understanding and improving agricultural system. Next one is investors. Agricultural yield predictions can be benefits for investors in the agriculture sector since they can influence investment decisions. Next, functional requirement. Data gathering. Two elements are required for machine learning to work: data and models. In order to correctly train your learning model, make sure the data you acquire has sufficient number of fulfill features. Make sure there is enough rows because generally the more information you have better. The data is gathered from Kaggle, an online community and environment where data scientists can compete with another. To solve problems in data science, dataset include more than 70,000 records with values like state name, crop name, area size, amount of participation in fall season. Next one is data processing. Label encoding is a data preparation method used on dataset. In the label encoding process, category data that expressed as a text is changed into numerical form. Since many machine learning approaches require numerical input data, this is frequently necessary. Feature selection. Choosing a subset of relevant traits to use in a machine learning models is a process known as a feature selection. About the forecasting of agriculture outputs, when selecting features for a crop yield prediction model, it is critical to consider which component are most pertinent have to be strongest predictive power. This model considers the name of the state, region, crop, area dimension, and quantity of rainfall. Model construction and model training. Model construction using machine learning, a production forecasting system must be built. Two major steps are model constructions and model training. Model creation refers to the process of developing and utilizing a machine learning model. It frequently involves selecting a model type and also appropriate techniques and tactics for the task at hand. K-means clustering and k-nearest neighbors classifier are the algorithm and methods utilized to create this model. Model training. Model training is the process of fitting a model to training the data. When presented with set of input data and the related accurate output, reducing the disparity between its predictions and the actual labels, the models modify its internal parameters. This procedure is repeated until the model's accuracy satisfies a predetermined standard such as mean squared error or mean overall error. Next one is model validation and result analysis. Model validation. After training, model is employed to make predictions based on new data. A new test data set can be utilized to judge the model's correctness and determine whether it is generalized to previously undiscovered data. If model's performance is subpar, further steps may be needed, such as hyperparameter adjustment or future engineering. Result analysis. Several methods are used to analyze the results for machine learning based prediction model. For agricultural productivity, to evaluate the performance of the model, compute various performance measures such as accuracy, precision, recall, and FSO. Alternatively, metrics like mean absolute error or root mean square error might be used to evaluate the model's efficiency. Analyzing the model's performance in comparison to the model is crucial. You can compare each model's performance to determine which is more effective. This could be applied to assist weight, advantage, disadvantage of each time. Deploying model using class. Making a machine learning model available to other users is known as deployment. This typically entails placing the model on a server or cloud platform and developing an interface that permits user to access the model and obtain forecast or suggestion. Next one is non-functional requirement. In this first one is performance. This model has the capacity to quickly process a large volume of queries and produce predictions. Next one is scalability. This approach is capable of handling more queries without suffering a significant performance hit. Reliability. Users always have to access to the model and there is a little downtime or error. This model is always accessible. Next one is security. The model is safe and guard against misuse or illegal access. This might entail steps like secure data processing and authentication. Although it aids in preventing unwanted access, this model includes register login page. Usability. The ability of a model to be comprehended, learned, and used by the user when employed in a particular situation. This type of offers customer setting that is friendly to learn them. Usability will impact some elements of functionality, dependability and efficiency, maintainability. Software modification capability. Mode is simple to adjust for changes in the environment requirement and functional requirements such as correctness enhancement. Next one is portability. The model's capacity to move between different environments. This paradigm can apply in a variety of environments, including organizational, hardware, software environment. The effective of the model remains unchanged when it is used to different contexts. Next one is system designs. The first one is architecture design. In this architecture design user interface from register and login page to cropped data, from that to actual model. Testing data and model building a phase. In this, three phases are there: user interface, model building phase, and evaluation phase. In user interface, register and login, cropped data and result. In model building phase, data sets and feature extraction, data splitting, model building like k-neighbors classifier, ridge classifier. And next one is evaluation phase. In that, testing data, model and actual model. Next one is data flow diagram. In data flow diagram, there is a context diagram. In that context diagram, external entities, process and data flow are the components of the context diagram. The external entities are the model and the users, and the machine learning algorithm is cropped prediction. The model will give data set and the formula will go back to the model. The information cropped and information of the model that was previously saved. The algorithm will forecast the outcome and deliver it to the user. Next one is process flow diagram. In this diagram, the gathered crop productions data set is analyzed in the data analysis phase of the process flow diagram shown above, and the analyzed data set is then used to showcase engineered ways. Data transformation include labels, encoding, data splitting, clustering, and data splitting into sections for training and testing. Label, classify, testing information sets are given to the algorithm for validation and testing. According to the reliability of the data and the effectiveness of the two algorithms, a model is then chosen for a decision making, and the new cropped data is to given to the selected model to predict the outcome. Finally, the model provides the set. The detailed designs. First one is use case. In the aforementioned use case diagram, the actors are the user and the models, and the use cases that are executed by the actors are login, logout, input data set, data splitting, train data model, test model, load model into Flask, user input, and view result. In order to input the dataset, data collection is required. Thus, we made the relation as include. Next, the model will divide the data into two parts, the training dataset, the testing dataset. The model is loaded in the front end after it was trained using the practical data and tested on the testing dataset. If you want to use the application again, the end user should first log in. After registering, the user can access the application by entering their email address and password. The end user must supply details such as the state name, area, amount of rainfall, season, crop after successfully logged in. The user can view the outcomes after the model provides the result of the specific input. Next one is sequence diagram. There are various lifelines and messages in the sequence diagram above. User attributes, classification, results, dataset, login, admin are the lifelines. The admin will first submit the dataset which will acquire after which the models will be built. Classification will be produced based on the previous data. The user logs in using their username password, then enters the classification critical that will be used by the model to classify the user's findings. Next one is class diagram. The user in the class diagram above has properties such as username, email address, password. He can register with the system or login, and the user data is kept in a database, which is an Excel sheet made by the administrator. An algorithm can be chosen by the administrator to generate a model based on performance and accuracy metrics. He can select from a variety of algorithms, and by using the algorithm he is able to develop a machine learning model that forecasts the result using recent user data. For crop yield prediction, user can supply the model with fresh crop yield data and the model will return result. Next one is implementation. These are some screenshots of my coding part. This screenshot is the aforementioned screenshot relates a front end created with Python and Flask. Here we have imported the necessary libraries, categorized the classes according to the appropriate values, and opened a model using with statement of open function in the RB mode. The RB mode does this by opening the file in the binary form for reading. The next screenshot shows that state label, season label and crop label have each been applied to the relevant state data, season data and crop data in the example, and developer predictions tool utilizing to get post protocols. The server responds to get request with data, and post request it is used to submit HTML form data to the server. This function primarily receives user input and returns the result to the user. The next screenshot shows that here we have developed the function for predicting rainfall in a specific state during a specific season. It forecasts the amount of rainfall for the data using the get post methods after receiving the user's input on the state and season name. Here is screenshot 4. Before signing in, a user must register using a mail, username and password using the function we have written below. After successfully registration of the user, the information including the user's mail, name, password is saved in an Excel sheet, so that the next time they want to log in, all they have to do is just input their username and password. The last one is define functions to allow users to log out of the both board simply hitting logout link at the top of the page, which then takes them to the login page. In this, we have loaded the various libraries required built on the top for forecast model. The various libraries including pandas, numpy, warning, cbor and matplotlib. We have also loaded obtained dataset for use in further steps. The next screenshot shows that according to our examination of the data, there are 74,975 records with 5 columns. Fortunately, there are not any null values in the dataset. Therefore, we have tested the next. This diagram shows that lower outlier of those are equals in contours below, and higher outliers are those areas with contours over 0.90. To make the state counts simpler to compare to display the quantity of course for each state a pie chart. This pie chart shows that. And next one is similar to last example. This one used to also horizontal bar graph to show the season count. This graph shows the season counts, which is in the blue color. There are 6 different sort of seasons, each with a different count. This one is shown due to the fact the various forms of crops have different counts. We have utilized a bar graph to illustrate the crop counts in the article. The next coding part says that since the state name, season name and crop name in the aforementioned screenshot are categorical factors, we must convert those categorical values into numerical values. Due to fact the various forms of machine learning algorithm can only work with numerical data, this stage model creation is essential. These are some output screenshots. First one is sign up page. This one shows my sign up page of the project. In this you can enter name, email and password. Next one is login page. After the registration page, login page will arrive. In that you have to enter email, password and then you can sign in. And this is the home page. In this rainfall prediction and corporate prediction you have to fill. Next one is result. Rainfall prediction. After the putting inputs, it will show the rainfall prediction. Already shown in the figure, rainfall prediction in Jharkhand in the season of Kharif is 3150.8. Crop yield prediction. After the rainfall prediction, it will show you the result of crop yield. It is good, very good or average. Next one is testing part. Test cases. Instance of tests using specific set of inputs and desired result, the efficiency of ML model is evaluated to ensure that the model is functioning effectively and making accurate predictions. Test cases are used. And this is the front end test case. In this we have tested 5 cases. First one is test case name, test input, expected result, actual result, status. First one is sign up, then you have to enter name, email, password. Expected result is registered successfully, actual result comes registered successfully. The status is passed. Next test case is sign up, name and just email. We have expected result successfully registration, but we get please fill out the password, and the status of this test case is failed. Third one is sign up, name and password. We expected result, registration failed, and it shows actual result. Please fill out the place email, and this status will also fail. Next one is sign up. Next we have to enter just email and password. After that we expect registered successfully, but it shows please fill out the place of name, and the result is failed. Next one is sign in. We enter email and password. We want login access, but it shows invalid login. Try again. Failed. Next one is backend. Backend test case has test case name, test name input, expected result, actual result. The next chapter is conclusion. Finally, the model's conclusion is that it is primarily helpful for farmers who are having trouble growing their crops and who have lack knowledge on what to grow and when under specific condition as a result. This model aids in their decision making, improve production and has negative impact on farmers' income. This project will help farmers to grow their economy and grow their crop in better way. It will help their economic and it will useful for them. The future work for this project: improving pre-processing and data gathering. Predicting agricultural output is difficult in part because it requires access to high quality data on a wide range of potential determinant of crop growth. Future information gathering on agriculture condition may be possible with the aid of cutting-edge technologies like satellite photos, sensors, and drones. Second one is the development of new machine learning model. The many machine learning techniques can be used to estimate crop productivity. The fresh models are constantly being created. Research might concentrate on developing models that are more precise, effective, or better suited to particular crop varieties or growing environment. The examination of climate change consequences. It is anticipated that as the environment changes, so will the elements affecting agricultural growth. The progress of model that can forecast how worldwide changes, like for future study, might concentrate on how climate change may impact agricultural production. Next one is additional uses of artificial intelligence in agriculture. Crop production forecast, it is just one of several problems facing in the agricultural industry. Machine learning may also be used for address challenges like insect management, irrigation and soil management to boost sustainability and agricultural output. These are some references for this project. First one is Vinathari S, Misra P, Singha CD, Data Mining Techniques for Predicting Crop Productivity, a review article in IJCTST 2011. The second one is Ramesh T, Vishnu Vardhan V, Data Mining Techniques and Applications to Agricultural Yield Data in International Journal of Advanced Research in Computer and Communication Engineering in 2013. The authors of this third one is Thomas van Klompenberg, Alo Cashoun, Cate Cattle. Crop yield prediction using machine learning 0168-1699 2020 Elsevier BV. Fourth one is Naka Venugopal, Aparna S, Jinsu Mani, Rima Matthew, Professor Vinu Williams. Crop yield predictions using machine learning algorithm NCREIS 2021 conference proceeding. The fifth paper is Ashwini I, Patil, Ramesh A, Medar, Vinod Desai, crop yield prediction using machine learning techniques in 2020 IJSR SET. Thank you.